everyone, welcome back to my channel. Your destination for mastering maths and physics is scoring high in your exams like GCSE, A-levels, TMUA, etc. Well, in this video we are going to learn what are increasing and decreasing functions, the difference between increasing or strictly increasing and similarly decreasing and strictly decreasing functions, and how to find them using calculus. So we're starting with increasing and decreasing functions. So let me start with the basic definition of it. So a function is increasing in a given interval if it keeps on increasing strictly within that interval. Say for example, if I'm saying this is my curve, it's like this. You can clearly see it's a strictly increasing, it's basically increasing. Now, given that if it's increasing, not necessarily that always a function has to be increasing throughout. In a particular interval also, if it's continuously increasing, we can see that it's an increasing function. Similarly, if in a given interval, if it's decreasing, we can say like it's continuously going down, we can say it's a decreasing function. So this is our function, and you can clearly see, let's say this point be A and this point be B. It's continuously increasing in that given interval. So I can say that a function is increasing in an interval if, as the value of x increases, the y value is either increasing or stays the same. So there comes the definition of two things, that is increasing and strictly increasing. Say for example, if I'm taking this example, let's say this is the function, this is our parabola. Let me just draw upside down this one. In this case, it's divided into two different parts. If I'll divide like this, I can clearly see the left part is increasing continuously, whereas the right part is decreasing continuously. So we have to focus on the first part. Here, suppose this is 6 and this is 0, so negative 6. So from x equals -6 to 0, it's actually increasing continuously, and from 0 to, let's say this be 3. So from 0 to 3, it's decreasing continuously. So this one from 6 to 0, it's increasing, but if I'm taking the value of 0, at 0, it's neither increasing nor decreasing. It's a stationary point, and stationary points are always the turning points where the graph changes its nature from decreasing to increasing or increasing to decreasing, which we can clearly see it was increasing and then changed to decreasing. It has changed its behavior. So that point after which it will change its behavior is a stationary point, and this is the point where the graph is neither increasing nor decreasing. Now here comes the difference. If we are considering 0 in our interval, then we will be saying it's increasing. But if we are not taking 0, that means that stationary point, the point where the function is neither increasing nor decreasing, if we are excluding that, that means we are not even taking that stationary point. So all the other points are increasing, so that interval is called strictly increasing. So like in calculus, how we solve it, I mean geometrically, graphically, you just draw the graph and you'll get to know like between which point it's increasing or decreasing. But in calculus, what we have to do, if we have the equation of a function, it would be f dash x, that means the derivative, the differentiation of that function should be greater than 0. In that case, it's strictly increasing. And if f dash x is greater than equal 0, then this is increasing, because obviously we are taking the consideration of 0, that I mean f dash x is equals to 0. We are including, and we know what is f dash x equals 0. This is the point We just did the tangent in the previous video where I have explained you dy over dx. That give you the gradient of the tangent. That means that will give you the gradient of the straight line. So if the gradient of a straight line is 0, that means it's parallel to x-axis. And if it's a parallel to x-axis, that means obviously it's a stationary points. So it's either like the peak point or the minimum points. These are the stationary points. And in that case, we'll get f dash x equal 0. That is, the gradient of straight line will be 0. And if I am including that, then this function is called increasing function. So if I have to define its definition, so I can say if x1 is less than x2, that means 1 I'm talking about. If one value of x is lesser than another value of x, let's say this point be x1 and this point be x2, and if x1 is smaller than x2, and we know the corresponding value of y will be fx1 and this is fx2. So if x1 is lesser than x2, then f of x1 should be less than equals to f of x2. So that will give me the increasing function. Whereas if fx1 is less than fx2, then it would be called as strictly increasing function. But which will help me? This part will help me in finding whether the function is increasing or decreasing. So if the derivative of it is greater than 0, then it's increasing. And if we are including 0 as well, that's increasing. And if you're not including 0, that means f dash x is greater than 0, not equals to. In that case, this is called strictly increasing. So let me show you one question. Say for example, we have a function f of x is equals to x cubed. So let me find f dash x. This will give me 3x squared. Now clearly I want to know like this is increasing or decreasing, and what would be the domain and what would be like basically the value in which I'll get it increasing or decreasing. So clearly it doesn't matter which value of x I'll put it here, I'll get it always positive. That means f dash x is greater than equal 0. Obviously, if I'll put 0 here, then I get 0. But whether it's a negative value or positive value, I'll get definitely all the values as greater than 0. So I can say it's increasing. And if I'll remove this one, like this, then I would be saying it's strictly increasing throughout the domain. Now, taking one more example. It's given as f of x is equals to 3x to the power of 4 minus 3x squared plus x. And we have to find whether it's increasing or decreasing or strictly increasing in that interval 2, 4. So what I'll do, I have to differentiate it. So f dash x will be 12x cubed minus 6x plus 1. Now substitute this value first. So 12 times 2 cubed, which is 8, minus 6 times 2 plus 1. Clearly you'll get the positive answer. And on substituting 4, obviously 12 times 64 minus 6 times 4 plus 1, that means obviously I'll get positive value, which shows that, and I'm not getting 0 as well, but you can check it. If that it is changing the sign, that means in that interval in between we can get the answer as 0, but here it's positive, this is positive, that means obviously it's increasing all the time. So that will give me, or also what you can do, you can just substitute this value. We know 2 is greater than 4, lesser than 4. So similarly f2 should be lesser than f4, and if it's so, then again I'll be saying it's increasing function. So I can clearly see this is increasing, and more specifically because it's not including any 0 value, no stationary points, it's strictly increasing. Now if you see this parabola, you can clearly see that this is the stationary point, this is the turning point, and this here the tangent. If I'll calculate the gradient of the tangent or the gradient of this particular point, I'll get to know that this is 0. So if I'll draw a tangent at this point, the gradient of this tangent is going to be 0, and this tangent is parallel to x-axis. That's the reason. Now, why this is a stationary point? Because from infinite somewhere it's coming, but it's continuously increasing. This whole left hand section is entirely completely increasing till this point. And this point, after this point, it starts to decrease and keeps on decreasing. So what's happening here, that at 4,4 it has taken a turn. That's why it's called turning point. And here the gradient is 0, or I can say the point is neither increasing nor decreasing, so it's called stationary point. Now the next question says, for which interval f of x is equals to x cubed minus 4x squared plus 4x is increasing. So we know that this is going to be an increasing function, but in a given interval. Just like if I say a parabola is neither increasing throughout nor decreasing throughout. It's in a partition, like half part will be increasing, half part will be decreasing. Similarly, this curve is also increasing in a particular interval. So which we can easily calculate by finding the derivative of this one and making it greater than equal 0, because that's the condition of increasing function. So on differentiating, I'll get 3x squared minus 8x plus 4 greater than equal 0. Now this is a quadratic inequality, and to solve this quadratic inequality, I should know the roots of this equation. That means the x-intercepts. So for that, obviously I need to equate this to 0. The product should be positive 12 and sum should be negative 8. So two numbers are negative 6 and negative 2. 3x squared minus 6x minus 2x plus 4 equals 0. Taking out 3x is common, it's 6 minus 2, and here minus 2 is common, x minus 2. Now the final are 3x minus 2 and x minus 2. From here I'll get x1 as 2 and x2 as 2 over 3. So if I'll draw it here, this one, and if I draw this curve like this, then my x-intercepts are this one, 2 over 3 and 2. Because our inequality is greater than 0, so we have to keep that in our mind. This is positive. This parabola divides this whole into 3 regions: the positive, negative, and positive. It's greater than equal 0. That means we have to find the positive region, because greater than equal 0 is actually what, right? It's the value. And when I will get the positive, when it's greater than or when it's above the x-axis. So that means this region and this region will give me the range. So I can say for all the values that are lesser than 2 over 3, so negative infinity, comma 2 over 3, or you can say union 2 to infinity. So that's basically will give you the domain under which this particular function is increasing. Now decreasing function works opposite. That means, let's say these are 2 points, x1 and x2. Clearly x1 is smaller than x2. If you see in this graph, x1 is 2 whereas x2 is 5, and we know 2 is lesser than 5. So x1 is lesser than x2. But if x1 will work opposite. In the previous one, if x1 is lesser than x2, fx1 was also lesser than fx2. That means if x is smaller, y is also smaller compared to the other one. But here it works the opposite. You can see that x1 is increasing to x2. I mean, we can clearly see x2 is greater than, but this y is decreasing. So fx1 is greater than fx2. So opposite thing is happening. When x is increasing, y is actually decreasing. And hence this is a decreasing function. Similarly, if fx1 is greater than fx2, then this is called strictly decreasing. We are not taking consideration of 0, 1. Okay. In this case, when they both are equal, that means they both are actually the same point. So that will become a single point clearly, right? So that consideration we are not taking. And other way of clearing or understanding the decreasing function is the f dash x. So if f dash x is less than equal 0, then this is called decreasing function, whereas if f dash x is lesser than 0, it's strictly decreasing function. We are not considering f dash x equals 0 at all. That means that stationary point where the function is neither increasing nor decreasing, we are not taking the consideration of it, and it's strictly decreasing throughout. So such functions are called decreasing functions. Now we know that if the function is decreasing function, the derivative of it should be lesser than 0. If it's increasing, should be greater than 0. But why we are doing it? I have already explained you in the first lecture that dy over dx, that is the derivative, is nothing but the gradient, and gradient of the curve keeps on changing. So either geometrically we can draw the tangent to get the answer, or in calculus we have to find the gradient by finding the derivative, which is dy over dx. That means the gradient, if I draw it geometrically, this is clearly, I can see, is increasing function. This first one is obviously an increasing function, it's increasing. So if I draw a tangent at this point and calculate the gradient of this one, you'll get that this one has a positive gradient, that means greater than 0. That's why for increasing function dy over dx should be greater than equals 0. Whereas, or in strictly increasing function, it has to be dy over dx greater than 0. Similarly, if I'll draw the tangent here, so the gradient of this tangent is definitely negative, and that's the reason we take dy over dx as less than 0 or less than equals 0. Now there are two formulas to calculate the gradient. One is, y2 minus y1 over x2 minus x1, and another one is tan theta. So dy over dx or gradient is equals to tan theta. This theta is acute, and we know tan acute angle is always positive. So just by looking at the angle, you can easily understand that your gradient of the straight line is positive or the negative. The gradient m that we are calculating of straight line, that is going to be tan theta. Similarly, here tan theta will be obtuse, and that means this is negative, and we'll get to know that dy over dx should be less than equals to 0. So this is basically the graphical interpretation or geometrical interpretation of why we are finding the derivative in our calculus part. If we do some question, it says state if f of x is equals to x cubed minus 3x plus 4 is increasing or decreasing and given domain 0, 1. So what we need to do is, we know that if dy over dx is greater than 0, it's strictly increasing, and greater than equals 0, it's increasing, whereas dy over dx is less than 0, it's strictly decreasing, and less than equals to 0 is decreasing. That means this will give me increasing, this will give me decreasing. And there's another definition, that means if I'm taking two values, x1 and x2, in this case x1 is 0 and x2 is 1. So when I'm calculating fx1, that means f0 and fx2, which is f1. So here we can clearly see x1 is smaller than x2. So if we will find f0 to be smaller than f1, then it's going to be increasing. But if it works opposite, that means if x1 is smaller than x2, but if fx1 comes out to be greater than fx2, the opposite will happen. That means f0 will come out to be greater than f1. In that case, I'll be saying that this is a decreasing function. So you can apply any one of them. So I think putting the values directly will be much more easier. We can opt this one. So that means I just need to sub in the value of 0 here. So when I substitute 0, that means f0, we know that 0 is smaller than 1. Now I have to see whether f0 is smaller or greater. So f0 is directly, it will give me 4, and f1 will give me 1 minus 3, which is 2. So f0 is greater than f of 1, whereas x, that is 0, is smaller than 1. The reverse, the opposite is happening. Hence, this is a decreasing function in that given domain. You can differentiate it and substitute the value of 0 and 1, and you can see whether you're getting greater than or lesser than. That means it will prove that this is increasing or decreasing. It says, for which interval f of x is equals to x cubed minus 4x squared plus 4x is decreasing. Obviously, in this case, the 2 points, the range, the domain, that's not given. So we will be opting the first definition where we have to differentiate it and make it less than equal 0, because that's a condition for decreasing. That means f dash x should be less than equal 0 is a condition for decreasing function. So let me differentiate this. This will give me 3x squared minus 8x plus 4 less than equal 0. Now this is quadratic inequality, and to solve the quadratic inequality, we first have to calculate the roots of the equation. That means the zeros of the equation. For that, I just need to equate this equation to 0. The product is 12 and sum is negative 8. So negative 6 and negative 2 will be the two numbers. That means 3x squared negative 6x negative 2x plus 4. Taking out 3x as common, x minus 2 and minus 2 as common. So this will be x minus 2 equals 0. That means my first value of x is 2 and another value of x will be 2 over 3. Now, it says the interval. So, for that, I have to draw this one. I get to know the x-intercept. X-intercepts are 2 and 2 over 3. That means 2 over 3 would be here and 2 would be here. So, my curve will look like this. And obviously, it's passing. So, let me just, like this. So, that means this region is positive region, because now this whole parabola is divided into 3 regions for the inequality. This on left hand side, this is a positive region because it's above x-axis, and we know all the values of y are positive above x-axis. This one is negative 1 and this one is positive. Now, less than equal 0, that means we have to look out for where y is less than 0. Y is less than 0 below x-axis. So we have to select this region. So my final answer will be, the interval would be 2 over 3 to 2. And the square bracket represents that we are including 2 over 3 and 2 as well, because it's less than equal 0. If the inequality is just less than 0, so then in that case we will be excluding 2 over 3 and 2. Moving on to the next question. State the domain in which f of x equals x squared minus 4x plus 3 is strictly increasing, part B decreasing. For strictly increasing, it has to be f dash x greater than 0. So the differentiation of x squared minus 4x plus 3 is 2x minus 4 greater than 0, and 2x greater than 4x is greater than 4 over 2, which is just 2. That means all the values that are greater than 2 is the domain, so 2 and infinity, and obviously we are not including 2, so we have to put it in a small bracket. For part B, it's decreasing. So for decreasing, it has to be f dash x should be less than equal 0. It's not strictly, it's just decreasing, so we can include the stationary point. So again, same differentiation will be 2x minus 4. 2x minus 4 should be less than equal 0. So x is less than equals 2. That means all the values that are lesser than, so you can write x greater than 2 in this case, and either way you can represent the inequality. And here the domain is minus infinity to here sorry, it's 2, and here it's 2. So 2 we are including, so it has to be in square bracket and like this, or we can write in this way. So in either way we can represent the inequality. So that's it for today. In the theory part, I always give you the basic requirement and very simple questions. Don't expect me to explain very harder question in the theory part. That we will be doing in a worksheets, and worksheets are designed in such a way that we'll start with simple question and then slowly move on to some harder questions. So in these videos, in theoretical videos, I'll introduce you with the theory required and the basic structure of the question where we can apply these, and in worksheets we'll be doing the exam related questions, some harder, some simple, and all the type of question that you will see in your exam. If you're looking for one-on-one live online classes for A-levels, you just have to email us at akzacademy@gmail.com to book a free demo. The classes are starting at just £8 per hour. And also if you're looking for GCSE classes or for any classes for any subject, just email us at akzacademy@gmail.com. We'll book free demo. We have the experts, and obviously we are happy to share all the results. We're pretty much happy. If you want, we will do that. So that's it for today, and also you can access these free worksheets on our website, which is akzacademy.com. So that's it for today, everyone. Take care. Bye.